Hello everyone, welcome back to my channel. In this video, I'll be covering multiplication theorem for conditional probability. So let us take the question on multiplication theorem. There is a question on, there's a lot which contains 12 items, out of which 4 are defective. So, and we have drawn 3 items at random, one after the other. Write a SCILAB code to find the probability that all 3 are non-defective. So what is the probability that we are drawing 3 items from a lot and those all 3 should be non-defective? So let us see the theory part of it and then we'll come back to the SCILAB code. So in all, we have total 12 items with us, out of which 4 are defective. So how many are non-defective then? So non-defective items are going to be 12 minus 4, that is 8. All right. And we have to draw 3 items. We have to draw 3 items at random, one after the other. So let us, what is the probability that all 3 will be non-defective? So what it is going to be, how do we find out the probability? The number of non-defective items upon total number of items, that is the probability of drawing the first non-defective items. So probability of me drawing first non-defective item is going to be 8 upon 12 because there are 12 non-defective items and total number of items are 12. Sorry, I just made a mistake. There are 8 non-defective items and the total number of items are 12. So probability of me drawing first non-defective item is going to be 8 upon 12. Then we have to draw the second item as well. And what is there? So we are going to put the multiplication. Okay. Then what is the probability of me drawing second non-defective item? Since we have already drawn first non-defective item, so how many non-defective items are left with me? 7. Initially, I had 8 non-defective items. After removing 1, I am left with 7 non-defective items and the total number of items are going to be 11. All right. Then we have to draw one more non-defective items. So, and what is there? So I'm going to put multiplication sign. Now, after removing 2 non-defective items, I am left with 6 non-defective items out of 10. So this is going to be the answer of your required question. So probability that I'm storing the variable P, and in the next line I will display. So this you're going to solve it and you're going to get the answer of this question. Now let us see how the code has been written on this. All of us know what will be the first line is going to do. The first line is just going to display what is written in the double quotes. What it is, a lot contains 12 items, out of which 4 are defective. 3 items are drawn at random from the lot, one after the other. So the same statement as it is will be printed on the console window. Then we have defined a variable S, which stands for total items in the bag. Remember, whatever we write after this 2 lines, that is called as comment, and that is only for us, not as that is not read by the SCILAB software. All right. So I have defined one variable S over here in which I have stored 12. Okay, because there are total 12 items with us. Then I have defined one more variable D, which stands for number of defective items. So how many defective items are there in the bag? There are total 4 defective items. All right. And what we have to draw? We have to draw 3 items and that should be what? Non-defective. All right. So here I have defined one variable, that is PF. PF stands for probability of that first item drawn is non-defective. So PF stands for probability that first item drawn is non-defective. So how many non-defective items will be there? S minus D. S was the total number of items. D was the number of defective. So if you remove defective items from the total items, you'll be left with non-defective. That is why S minus D is there. I hope you all have understood how S minus D has come. There were total S items. The total items we have stored in a variable S. Then we have defined one variable D in which we have stored total defective items. So how many are non-defectives? Non-defective items will be S minus D. That is why S minus D is there, because we have to draw non-defective items upon total number of items, that is S. All right. This was the probability of drawing first non-defective item. but we have to draw 3 items. So let us see the formula. So first non-defective we have stored in a variable PF, that is why I have written PF. Now this multiplication, I hope this you have understood why multiplication has come, because we have to draw 3 items. So after drawing first item, you have to draw the second item. So and what is there? So you are going to put multiplication sign. Now, once you draw S minus D item, how many items are left with you? Non-defective S minus D minus 1, because you have removed total non-defective items were S minus D. Since you have removed one non-defective item, so we are left with S minus D minus 1 items for the second row. So here S minus D minus 1 I have written upon total number of items are going to be 1 less. So 1 less is S minus 1. Now we have removed 2 items. So how many non-defective items are left with us? S minus D minus 2, because total non-defective items were S minus D, and since we have removed 2 items, so there we are left with S minus D minus 2 items upon S minus 2. So this we have stored in a variable PE, and in the next line we are displaying the value of that variable. What is this variable stands for? Probability of all 3 items are non-defective. Here you can read in the comment line also that what it means, how the formula has come. After the first item is chosen, the second item will be chosen from 1 less than the original number of items in the box. And similarly, the number of non-defective items gets decreased by 1. Similarly, for third draw of items from the. So let us execute this code and see the output of it. So here you can see that I have copy pasted the code over here. Then you're going to execute this code. And here you get the output on the console window, which is 0.2545455. Okay. So you can see here the value has come up first and then the statement is coming. So here I'm going to modify our code. So this PE, instead of writing at the start, I'm going to write after the statement. All right, and then again I'm going to execute it, and here you can see the probability of that all 3 items are non-defective is 0.2545455. And in the first line I had written that a lot containing 4 items, out of which 4 are defective and 3 items are drawn. That is getting printed as it is. All right, so that's it. Thank you for watching.